Hello, this is Yannis from Repair. Today we will go through a repair of a Legion 5 notebook that came to our lab dead. Let's go and see how we will deal with this. Now, here's the board. We will have some measurements with our multimeter. I have removed the battery connector for that. So let's go and see some rails, some coils with our multimeter in diode mode. This was the PCH supply. This is the 3.5 volt, which are okay. This is the maybe the RAM. Yes, this is the RAM. This is the PCH connection, and this is which cannot be seen, but I will adjust our overhead camera in order to have a better look at it. This is a little coil which is supplying 1.8 volts, and I think it's okay. And now we must have a look and remove, obviously, the CPU and GPU heatsink in order to check for other coils and determine what's wrong with it. We'll go faster to remove the heatsink, to reveal the board beneath it. Okay, the heatsink is out. We will check the CPU coils, which are okay. This low value is okay because the load CPU has a very low resistance, so it is okay, no worries about that. Double check. We will go to this coil too. Maybe it is a system agent. It's okay too. And now we must go to the microscope view and check further, as we are not having any shorts on coils. And what we want to discuss today is the buck converter setup. The buck converter setup is something like that. It is normally, two MOSFETs connecting with a coil and some capacitors that are filtering the input of the voltage, like that capacitor, which it is not good, and I will display the multimeter in order for you to see it. This filter, this capacitor, it's not good, as you can see. It is filtering the main rail on the upper MOSFET of both coils. One is the ground, one is the main rail, so we can assume that we are having a main rail short. Just check it. This is an alternative way to detect a main rail short, just to check filtering capacitor in the main rail. It's not a short on the MOSFET because the MOSFET should have the same value with the coil. The coil and the main rail should have the same value in this measurement in order to have a broken upper MOSFET and maybe a dead core or a dead GPU or a dead load IC. We're double checking all the filtering capacitors in the area we can see in order to be sure. But I think we have this main rail short, which is very good because main rail short is a thing that we are wishing to confront because just a simple injection with voltage can reveal the culprit. So let's go check again. You can see main rail short, and now we must find a jumper to solder a wire in order to inject some voltage and see what is happening with the thermal events on the board. This is a jumper which is feeding, as you can see, this IC that is driving the PL1901. We have the red wire on this jumper, and the black wire will go to a screw. We will solder it in a screw pad that is always the ground, the board. And now it is the time to inject 1 volt, as you can see, and use our thermal camera to inspect if something is getting hot. We will connect the camera to the Ethernet and to the 12 volts. And now we can check for thermal events that happening from the shortage that is happening on the board. We can see that is 1 amp and something. So let's go and see what is getting hot. What is getting hot is filtering capacitor, maybe the one that we have already checked for sorting. We will go and use our microscope after removing the thermal camera. And with our microscope, we will split some isopropylic alcohol in the area that the inspection of the thermal camera was very shiny, and the evaporation of the isopropylic alcohol we will reveal visually the culprit. I think this is the culprit. So let's go and kick this capacitor out of the board and see what will happen. We will go and zoom on this capacitor and use our heat gun and our tweezer to remove it. Let me focus better. Now it's okay. You can see it happening now. This is the one for sure. So let's remove it. (462 Celsius), full air. This is what we're using in gaming boards because the heat consumption is very big. It is moving, it is off. The voltage and the amp meter is stuck. We're not desoldering with our injection on. We can see that we are having a good value of resistance between the ground and the main rail. So I think we are done. We are going to screw the heatsink back and check if we have solved the case or not. We will desolder the jumper wires, our custom DC jack. We will plug the battery back. And now with our multimeter in volts, we will check if the battery is feeding. Yes, it is feeding the board, which is telling us that no short is going on. And after we will press the power button with the battery plugged in. Yes, the backlight of the keyboard is on. Waiting for the display to come. This is it. We have display. So the fault is no more. We have solved the case. That was the repair as you saw. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.